Vector addition can be done by two different laws. The first law is the triangle law, while the second law is the parallelogram law. Let us take a look at the triangle law to see how it works. Before telling you the concept of the triangle law, let me explain the concept of the head and the tail. It's interesting.
When we have a vector like this part of the vector is called the head, while this part of the vector is called the tail.
If I have two vectors, vector A and vector B, and we are asked to find the addition of the two vectors, how do we do it?
If I want to add these two vectors, before adding them, we will have to join them for addition. The question will be, how do we join them for addition? There's a simple trick to do so. What is the trick? The head and the tail trick. Please remember this trick whenever you are joining vectors. It applies to all. How do I join this vector? Like you were told earlier, that a vector has the head and the tail. This is the head of the vector, while this is the tail of the vector. So to join these two vectors, vector A and vector B, what we are going to do is that we are going to produce vector A without changing either the direction or the magnitude. How do we do that? Just watch. I brought out the vector of A without changing the magnitude or the direction. The next thing we are going to do, since we are using the head and the tail trick, we are going to take the second vector, which is vector B, and join it with A. But before we join it, you must take note that the head and the tail trick, that is what we are using. So in using the head and the tail trick, the tail of vector B is going to meet with the head of vector A. The tail of vector B is going to meet with the head of vector A. Please watch. So when you have joined the tail of vector B to the head of vector A. The next thing we are going to do is that we are going to add the vectors. How are we going to add these two vectors? Remember that when joining vectors, I said we are going to use the head and the tail trick, which we have done to join the two vectors. So to add these two vectors, vector A and vector B, we will need a resultant vector to add them up. So since here is the tail of vector A and here is the head of vector B, what we are going to do is that the resultant vector will join the tail and the head together. So this is what we are going to have. So by the time we have joined the tail and the head together, what we have here is the resultant vector. So the resultant vector, which is called R, is equal to A plus B. So the addition of these two vectors, vector A and vector B, is R is equal to A plus B. So generally, this is how we add vectors. Tentatively, if we are asked to find the sum of vector B plus vector A, how are we going to do it? This is how to represent vectors. The arrow on top of the B simply means vector B. Now, how are we going to get B plus A? Since we are asked to get the sum of B plus A, then we produce B first without changing either the magnitude or the direction. Now, since the trick is the head and the tail trick, the tail of vector A is going to meet with the head of vector B. So the tail of vector A is going to meet with the head of vector B. So this is how to join the two vectors. The next thing we are going to do is to sum up the vectors. How do we sum it up? We are going to get a resultant vector that is going to join from vector B to vector A. The resultant vector R is equal to vector B plus vector A. In our next series, we'll be looking at why vector addition is commutative. And also, we'll be looking at the second aspect of vector addition, which is the parallelogram law. All you just need to do is to